All right, folks, it's Bass Action, back in action here. In this video, we are going to go through how to write the equation for a secant or a cosecant equation based on a graph. I think that these can be a little more complicated because you've got to add a little bit more steps because the secants and the cosecants were the reciprocals of our sines and our cosines. So let's take a look at our graph over here. And one thing that might be a little bit hard for people to see right now is what the original graph might have looked like. So just like our sine and cosine, the first thing that we want to do is we want to be able to visualize, looking at these highs and lows here, we want to be able to visualize and draw it in maybe where that center line would be. So we're going to go ahead and we're going to draw that center line in because that's going to help us quite a bit. So I'm going to draw in a center line right here. What that allows me to immediately see is that there is a vertical shift that's going to go up to, and it allows me to visualize and count this distance easily and see that there's a vertical stretch of 3. So similar to what we did for our sine and our cosine, we're going to come down here to these two equation boxes, and we're going to start building our equations right away because the more we can connect what's the same is going to make these a little bit easier for us. So they're both going to have the same vertical shift. They're both going to have the same vertical stretch. We can go ahead and write the cosecant. We can write the secant. And just like before, we're going to set this up with our parentheses so that we're all prepped and ready to go for any of our phase shifts. Okay. Again, we don't know if there's going to be a reflection or not, so we can't put that in. So we're just going to go back to our graph and see what we've got going on. Now, what I like to do is I like to actually kind of take these graphs and I like to start to sketch back in what the original graph would have looked like before I reflected it. So see, I like to sketch this in. It helps me visualize a little bit more what's going on and to be able to pick out my phase shifts. So here's what this shows me right away. If I look at this new blue graph that I've drawn in, I can see that right here on the y-axis, I have a high point, okay? This high point is going to tell me that this could be a start for a cosine graph, which means I can write this cosine graph or this secant graph ultimately with no phase shift. Certainly I could identify a phase shift of, let's say, pi over 3 or even this pi over 6 right here, but it's of course going to be easier to do it with no phase shift. So I know that when I get to the secant graph, I'm going to have no reflection and I'm going to have no phase shift. That's going to make things a lot easier for me. So I can already drop this in right here. I could even just drop in a -0 to remind myself there's not going to be a phase shift. Now, the next thing that I want to do, especially since I don't have a phase shift, I'm going to quickly find what my period would be. So just like we did before, let's do a nice little trace so that we can visualize the entire period. That's going to show me that I'm going to go from 0 to pi over 3. So my period in this case for secant or cosecant is going to be pi over 3. So now I'm going to have my pi over 3, and that's going to equal, remember, we found that period by doing 2 pi over the omega. And if you want to actually cross multiply this, we of course know that the pi's are going to cancel. You should be able to just cross multiply it or do it in your head, whichever one you want. We're going to get that our omega equals 6. That means that we can come down to our equation and we can drop in the 6 for the period change. So the secant equation is now automatically done. We don't have to do anything else there. For the cosecant graph, we're going to come along here and we're going to find where one of the asymptotes are, okay? So we're going to find this nice asymptote. Again, I could pick any one of these asymptotes as the place where I'm going to start my cosecant. I'll just go ahead and grab this one here to the right. Doesn't matter. If I start tracing that, I'm going to go down. So that means that my cosecant graph, looking at this in terms of a sine, this right here, starting here, would create a reflection. So the cosecant is going to have the minus right here. Now I need to know where this asymptote is, and we'll notice that on our graph it's not actually labeled. But what I do know is that this asymptote should be halfway between those 2 points. So the distance between the 0 or the midpoint, this distance is a pi over 6, and half of it would be pi over 3. Or I could think just finding the average of these 2 x values. If they've been shifted, that's a little easier. So that means that I'm going to have this as actually a pi over 3. So my cosecant phase shift is a pi over 3, and there is a reflection again. So I'm going to write minus pi over 3. So remember, I could have started right here. Then I would have gone up and I would have had no reflection there. And then I still would have had this as then a plus pi over 3 because I would have gone to the left. So lots of options on what I could do there, but just keep in mind any of these are going to have an infinite number of ways that we could write the equation. Typically, we will narrow it down based on very specific characteristics so that when you're writing them for us, there's only going to be one correct answer.